Hey everybody, this is Mr. Kimpton.
And Gilbert.
We're going to give you a quick little review of CCR, which we use all the time in earth science. Convection, conduction, and radiation. Make sure you learn that CCR. So you should be able to fill a grid out like this by the end of this short video and be prepared to do this at some point in class in the very near future.
Okay. Next, we're going to jump into a little overview slide of energy transfers or energy heat movement. And kind of remember, what is energy? What are the different forms of energy? We're talking electromagnetic energy, etc. What's on the spectrum? But as Mr. Kimpton said, we're going to focus on three main transfers: convection, conduction, and radiation. Let's get into details.
So conduction is the energy transfer by touch, or you also hear us say direct contact. So we actually have two things in direct contact with each other. So you can see the diagram here. The first, you got the candle over here on the right, and this person for some reason is putting a hot piece of metal in the flame because they don't know what conduction is. So you're touching the hot bar, and very quickly it conducts that energy across the bar to your hand. And that's pretty much it.
The next one is convection, and that's the transfer and movement of energy in liquids or gases. And we're going to learn a 4-step process to show this convection cycle or convection cell, just like what's here in the picture of how the energy is actually moved. So more details on that to come, but that's the basic overview.
And then radiation. Transfer of energy, it can be visible light, it can be micro, infrared. You'll get familiar with these throughout the year, but they travel in waves. They can travel actually through empty space, and some of these can actually travel through matter. Most importantly, they travel as waves.
So now back to details on convection, and we're going to use an example that occurs in Earth. But you could use these same concepts that occur in the air, in the atmosphere, in your classroom, in the lava lamp, whatever. And the first thing that happens is the hotter asthenosphere. That's what the A stands for. We have mantle M, A asthenosphere, L lithosphere. These are some of the layers of the Earth. And heat is in the mantle. It heats up the asthenosphere, and the hotter asthenosphere begins to rise towards the surface, or the lithosphere. That's number 2. It hits this solid lithosphere, and the liquid starts moving away. Number 2, hits an object, moves away. And notice, as it's moving away, it's getting farther and farther from the heat source. As you get further from the heat source, you begin to cool down. And that takes us to the next slide. Oh, next slide.
So as you get further away from the heat source, things are going to get cooler and cooler. As Mr. Gilbert said, when things cool down, they tend to condense, and things that are more dense sink through things that are less dense. And then it's going to essentially get pulled back in towards that heat source because it needs to fill in that empty space of where hot material is becoming less dense and rising. And that cycle just continues to go on and on and on as long as that difference in temperature and that heat transfer tries to balance out that difference in temperature between hot and not hot.
And we'll have lava lamps in the room showing this going on. The same thing occurs in the atmosphere. It's awesome, baby. So finally, can you fill out this chart? Can you define and draw all 3 types of heat transfer in detail? We hope you can. If not, watch the video again. Bye-bye.
Bye-bye.